Great. And I see that we have a few of our engineers on the line as well, who, in case anyone has problems that aren't solved quickly, they'll be able to help out. Great. We'll give it till the 5-minute mark. There's still a couple people trickling in. And like I said, for the people who just joined, yeah, there's a repo link. I'm putting it in chat. I'll also type it answer in Q&A. But it's here, I'll put it back in chat. Oh, it goes to host and panelists. Everyone got it. Sorry. So I should have just, it should be in chat now. So yeah, I recommend cloning that repo. Just because we're going to do it in a minute anyway. Great. A couple more minutes. So yeah, we'll clone that repo. For those of you who don't have Python set up locally, I'm also going to show you how to run this via Colab. Technically, you don't even need Git if you don't have Git. Is there anyone here who doesn't have Python set up on the computer they're on or Git? Just paste in chat if so. If everyone has it set up, then I can just go via the Jupyter route. I'll show both anyway, but if you let me know, then I will make sure to do that. Great. Let's should we just kick off, Shep?
Yeah, I think so.
Great. Well, hello, everyone. As you can see behind me, this is a workshop on using a feature store in your data science workflow. So we're going to actually use Featureform, which is an open source feature store, to build a fraud detection model. So we'll use it to register our files, transform them, build features and training sets out of them, actually train a model, and then use that model and make a prediction as if it was deployed. So we're planning to do a longer set of series. If this is successful or you find it valuable, please let us know. And we plan to run other ones for AWS, GCP, Azure, Databricks, etc. For this one, we're going to use local mode. The reason being, it's much easier to set up. You don't have to set up any infrastructure. And for us, honestly, this is our first workshop of this style. So it's a bit of, again, maybe be a bit of a learning experience for us too. So thanks for bearing with us and being our guinea pigs, honestly. Great. If you have any questions through this, please ask in chat or put it in Q&A. We do have a couple of our engineers online who, if there's a situation where you need help, they can actually chat with you and DM you and help you through any problems you have, if there's any. Hopefully, it's just all smooth sailing, but you know how it is. Great. So for those of you who didn't, I saw there's a couple people who joined as well a little later. There is a Git repo, which I recommend everyone clones. And I'm going to throw it in the chat again. And it looks like this. So you will see, yeah, this is the repo. It's really, there's just 2 files. If you do not have Git set up for some reason, that's fine. Post in chat just so you can let me know so I can walk you through. You won't have to because all we need is this one file and we can use Colab. But if you're following along, the first thing I recommend you do is git clone this into a directory. Awesome. So now that you've cloned, I'm going to switch to a different screen to show you all our terminal. So let's share that. So we'll clear this. So you should be in this repo. There will be 2 files in the repo. There will be the local mode webinar, transactions new. This is our notebook and the file that we will work with. Again, the goal of this webinar is to build a fraud detection model using Featureform. So first thing we should do is run Jupyter Notebook. So for those of you who don't have Jupyter set up, I'm gonna, I actually forget what the name of the package is in Python. But let me just check real quick. Okay. So what you can do if you don't have it is pip install Jupyter Lab or pip3 install Jupyter Lab, depending on what you're doing. So that should get you set up. Again, if someone doesn't have Jupyter or doesn't have Python or ever set up, please let me know. Just because if that is the case, I'll show you how to do it in Colab. Once you have it set up, we're just going to use the really simple version of Jupyter, which is just Jupyter Notebook. So you can just write Jupyter Notebook. Enter. It should move you to a screen that looks like this. Let me find my Zoom so I can share it. Share screen. It will look like, sorry, I have a lot of tabs open. There it is. It will look like this. Again, if you have any questions or anything, let me know. The other option, if you don't have Python Jupyter set up, is you can use Google Colab. In that situation, you'd go to colab.research.google.com. You would import the file, local mode webinar, and it will open something that looks like this. So that's totally fine too. Either way, you'll be able to follow along. So now you either have your Colab set up or you have your IPy notebook or wherever your Colab. So let's click into the notebook that we have here. So first thing we're going to do, I'm just going to run this while I talk, is pip install Featureform, pip install scikit-learn, which we're going to use to train a model, and pip install requests. Request isn't actually required, but if you're using Colab, you're going to want it because it's just easier to download the file in the Colab environment if you're not using GitHub. Awesome. If you're following along, let me know. I'm actually going to switch to talking over a few points about what we're going to do in this webinar. I mostly just wanted to run this because it just takes a while sometimes to pip install, or people might be getting their environment set up. So while those of you who are finishing off, feel free to take your time. Otherwise, and for everyone else, I'm going to talk about what we're going to do here. I'll start by talking about what Featureform is. So we call Featureform a virtual feature store. It's a way to define, manage, and deploy your ML features. It's used by data scientists. There's typically some sort of admin, especially if you have governance needs, and often by ML engineers or data engineers. There's a declarative API, which allows you to define your primary data sets, transform them, register features, register labels, register training sets, which you can then use to train your model. We also have a dashboard, which I'll go into. We have APIs for inference and APIs for training. What that means is you will define your feature once, your transformations one time, and be able to use them both in a production environment and in a training and offline environment. What Featureform gives you is a repository, like a single source of truth of all of the features and labels and everything you've built. It gives you the ability to collaborate. This is via search and discovery, versioning, lineage, sharing and reusing things. We offer monitoring and alerting for data drift and uptime, as well as governance, so that you can do, and governance is an enterprise, I should add, so it's not an open source, but it allows you to do access control, SSO, audit logs, etc., things you would need for governance. This whole application layer of a feature store is actually applied on top of your infrastructure. So Featureform acts like an orchestrator rather than actually being a new type of database. So the term feature store is kind of a misnomer here. We have a way to compute features you can plug in. So you can plug in something like Spark or Pandas storage like S3. If you're using the enterprise version, we also support streaming with things like Kafka or Flink. We support databases. We support caches like Redis and Cassandra and Dynamo for online inference and production. In this webinar, we will be using our laptop as the infrastructure. So this is local mode development. Local mode development, the goal here is really just to, one, show off the API, help you understand how Featureform works. You'll understand that it will be very, very similar in a production environment. You will just register things very slightly differently. And in practice, one thing that we're moving towards is actually making it so you can iterate locally, like you can grab something from S3, grab like a sample, iterate locally, and then start to define your transformations for production later. Great. So that's Featureform. And in this webinar in particular, or this workshop rather, we are going to use Featureform local mode to build a fraud detection model. Okay. If you have any questions, anything comes up, just put it in chat. We have some engineers who will be able to help out as well if there is a situation where it's going to be too far out of scope or I won't be able to like answer in line. Awesome. Let's start. So at this point, we should have ran, I'm going to use this one. We should have ran our pip install. Next, let's just import Featureform. Now, like I said, we're using local mode. So typically when you would be defining things, you would be defining them using like Redis and Spark and these other, we call them infrastructure providers that you register. In this situation, the infrastructure is just going to be your local laptop. And so we import local to act as that. So we'll run that. You might get some of these warnings. These are just related to how we print things. The next thing we're going to do, since we're treating this more like an experimentation step before production, we can do something called set run. Set run essentially gives everything the same version. So it's like grouping all the resources we're going to build together. So in the future, when we look at the dashboard, when we're looking at what we built or where it was built or where it exists, it's very easy to come back and find that. So we'll do that real quick. Great. Now, oh, there's a Q&A. You mentioned the virtual feature store. Can you please put a bit more light on it? What are the different types of feature store? That's a great question. I'm actually going to answer that question first before I get further into the code. So I'm going to go back to some slides. I actually was kind of prepped for that question, so I have them down here. There's three types of feature stores. There's the literal feature store, the physical feature store, and the virtual feature store, which is just kind of something we've invented. The literal feature store, some people just call this a feature store. So this is the architecture that Feast copies, that or Feast created, that Vertex copies, that Databricks' feature store copies, that Azure's, and all the different feature stores that exist sort of use this same architecture that we call the literal feature store. In the literal feature store, you will build your features. So you'll take your sources, you'll transform them in Spark, you'll orchestrate all that, you'll build your streaming transformations, and then you will copy the final result, the final values into the feature store. Now, the value there is that all your features that are in production ready are all in one place in one type of database. The con is that it's not actually tied to the transformations. So you don't get lineage. It's your job to actually run these transformations. If you want to update a feature, you can't really do that. You have to create a new feature table, run a new transformation. It's not really tied to any of that. So in practice, it's just a place to store features. It's a literal feature store. If you read about companies like Airbnb, Uber, et cetera, that built feature stores internally, their architecture does not look like a literal feature store. For them, they actually tie the transformations to the feature store. So now some people would call this a feature platform, where it has the transformation support. It usually adds monitoring. It usually adds scheduling. It adds all sorts of stuff that wouldn't exist in something like Feast. So this kind of runs the transformation, stores the values, and you define your transformations as logic and not as just data. So when I think of a feature, I think of it as, the last 5 items the user clicked. In this definition, that would be possible to define. In this one, it's just a row of data, and it's my job to build that row of data. The problem with the physical approach, and Tecton is one of our competitors, is another vendor that has taken this architecture. The problem we see with this is it's very heavy. You have to move all of your data into Tecton. You have to transform it using their APIs. That all kind of, it's like you have Databricks and then next to it you have Tecton. It's a very heavy abstraction, very heavy piece of infrastructure. We came to the conclusion that this is the right abstraction, but the problem is that it should have a plugin architecture. So you should be able to plug in your own transformation engine, your own storage engine, even if it's multi-cloud, even if it's hybrid, even if it's on-prem, it doesn't really matter. But the value of Featureform isn't that we are faster than Redis or we transform data better than Spark. It's that we provide a workflow, a framework to define, manage, and deploy your ML features over your infrastructure. So that was the approach we took. We took what we thought was correct, which is a feature platform over a feature store, but we built it sans any infrastructure hard pinning. So like it's completely virtualized on top of your infrastructure. It's a great question. Thank you. Okay, let's go back to code. So we ran set run. So now we've kind of told Featureform, hey, this is like our environment. We're ready to go. This is commented out. This would download the transactions file. If you're in a Colab environment or for some reason you don't have Git set up and you just set it up, you just downloaded the notebook, you would uncomment this and run it. I'm not gonna because I have the file. So the first thing we're going to do, we're going to use local. Again, if this was deployed, we would do spark dot or s3 dot this, or we would do something like, snowflake.register table. Because we're working locally, we use a local object that we imported and do local.register file. We give it a name. The version will automatically be set to webinar because that's the name of the run. And we specify the path, which in this case is just /transactions new. So we run that. Now, we can actually call client.dataframe. Client.dataframe will retrieve this as a data frame. So we can do that, and you can actually look at the data. So this is the data we're going to be working with today. We have a column, which is just the index. We have a column, which is the transactions number. We have our customer ID, customer date of birth, customer location, customer account balance, transaction amount, time of transaction is fraud. So this is the data set we're working with. So in a perfect world, our features would all just be here. Like when we learn data science, we act like the data's there, here it is, now build a model on top of it. In practice, as anyone who's worked in the industry will know, most of what we're actually going to be doing is feature engineering, which is taking our raw data and turning it into useful signals that our model can then use to actually do a good job. So let's start by doing that. So the first thing we're going to do is build a signal, which is percent balance. Now, percent balance is, it's a new data set. So in Featureform terms, this is creating a new data set. So this first thing was a primary data set. This is a transformed data set. This code is just pandas. If you were using Spark, it would be Spark code. We support SQL. So we support SQL and data frames, and in some cases, just raw native Python. And we're just defining a new column, balance percent, which is transaction amount divided by customer account balance. Now I have this dot replace here. This is to avoid situations where customer account balance is 0. That ends up with lots of infinities and nands getting thrown in. So I just replace it. If the customer account balance is 0, I make it 1. This is a hack. This actually makes it not necessarily be true because there's a situation where I have a transaction amount and the balance is 0, but this just makes life easier so I don't have to deal with infinities. So this code is exactly what you would write without Featureform, right? What we're doing with Featureform is we're specifying, 1, where this is running here locally. 2, is this a data frame or a SQL transformation? It's a data frame transformation. The inputs, because we're actually building a DAG here. So we're building a set of like transformation nodes and tying them together. And in this case, the input is the transactions thing that we just registered, the file. So obviously, like typically when you create something, you want to play around with it, you want to use it as a data frame. We have a client.dataframe API. So if you call client.dataframe and you put either the name of the object in the register, like in the register file, we have transactions. So we do client.dataframe on transactions. You can also do it on percent balance. So even though it's a function. So we run this. And you can see it created this new column, balance percent. And this is just a percentage of the balance of your balance is this transaction. That's great. One thing I want to do real quick before I go any further is I'm going to create a new cell. I'm going to do estimation, which is just like a CLI, just runs in CLI. I'll do Featureform dash. So this is going to run our dashboard. So I can run this. And it's going to create, it's going to run it on this directory, which I can click. If I go to sources, I can see transactions. I can see the one variant, and I can look at percent balance, that one variant. If I click on this, I can even see the code that was used to build that transaction. I can preview it. So I can click here and I can view some of the data that's in here if I wanted to. And yeah, I create tags and add tags if I wanted. I can look at different variants. I can see when it was created. I can do all sorts of stuff. Soon we're going to create some features, some training sets, some labels, sources, providers. Providers, we have one that's local mode. Users, there's a default user that gets created. If we had governance set up, we can actually type this to something like Okta. Great. Let's go back to the code. I'm going to come back here. I'm going to stop this because this is going to hang forever. Now, the next transformation I want to run is going to be a little more complicated. So here, what I want to do is take the average amount or the average transaction amount for the user. Now, you might wonder, well, couldn't I just do group by .mean? And the answer is yes, you could. But what you would miss if you do that is the timestamp. The point is when I build a training set, I'll have labels at different points in time. And for those different points in time, I want to make sure that my feature values are what they would have been at that point in time. So it's not just getting what the values would be right now, which would be very simple, but rather creating a rolling window so that I can maintain and keep track of what the values would be. So I take the mean and the count. I just take the count just to show you all how it looks. This is how it looks like when it runs, but I'm going to run it here. This takes a little bit. It's a heavier transformations. Our file has like 1 million and like 1.5 million rows, I think. It's relatively low. It's not huge, but it's running on your laptop and we're using pandas, so it's not exactly the fastest framework in the world. So we'll let this run. And again, like I said, this is a rolling window. So we're taking the customer ID or grouping by user. We're taking the transaction amount. We are doing a rolling window and we sorted by timestamp. That's fast, faster than I used to. We're sorting by timestamp, which makes it such that the things previous to it are going to be older. And we don't necessarily need it to be a full 30 window. We just want up to 30. So that's what the min periods is. Take the mean and the count, and then we reset the index after, just so that everything is a clean, nice data frame. Notice that in Featureform, all transformations return a data frame. That's just how they work. And at any point in time, you can call client.dataframe, and that will actually get it to you in data frame form. So here we can see the mean and the count. You can see the timestamp as well. So this is, notice that this is the same user, right? But the values changed because the transaction here actually lowered the average. That's a good question. How do I call pd.toDatetime if it was never imported? Great question. I actually noticed this right before I started running it, that I pretty much, this code is actually running within Featureform's framework. Featureform's framework is going to import pandas and a few other things. So I just did this without thinking. Typically, like if I was going to use a library that wasn't standard, I would have to do like import pandas as PD. In this case, I just got lucky that it's imported in Featureform anyway. So, but that's a really, really good observation. I was wondering if someone would catch that. I didn't even bother changing it because I don't like changing the code right before a webinar. But yeah, so this code runs in this case, it runs in the Featureform framework. If this was Spark, it would run in the Spark context. So same thing, you could do the same imports and it would work like a Spark function would, or Spark transformation would. It would require that you would import packages onto the Spark cluster. So there's that. But yeah, in practice, we happen to import pandas and a few other things. Great. So I have these data sets now. I have 3. I have purse balance, which is the main data set in one column, which is a percentage balance. I have the original one. And I have this new one, which has mean and count. It's called window ags. These are the names. So the name of the data set gets set as the name of the function. If we add a PyDoc, which I probably should have done for this just to show, this would get added into it as a description. And then the version gets set as the run. So when you did set run, now I can manually override that by doing variant equals v1. We don't call them versions, we call them variants. The reason being, typically with machine learning, like in metrics, v2 is typically better than v1. In ML, it's very common to have lots of different flavors of the same thing or the same feature. That's why we use the term variant and not version. Okay. Now we're getting towards the good stuff. So we have these data sets. Now what we want to do is specify which columns make up a label and which columns make up a feature. Notice that I'm not building a transformation here. This is more just like a tag, like I'm tagging specific columns as features and labels. A feature is going to be associated with an entity. What I mean is that you can think of them almost like a primary key, like a feature kind of needs a primary key. And in this situation, the feature would be tied to an entity, which we're defining here as user. We can also specify a label as tied to an entity if it is just tied to a single entity. So we'll have our label is fraud. It will come from transactions. Transactions was that original file that we registered. It's made up of 3 columns: the index, the value, and the timestamp. Now, why do we need a timestamp? Well, the answer is that you might have the same customer ID where one transaction is fraud, the next one isn't, then there's another one that's fraud. In that situation, you want the timestamp of this label because you would use that to calculate the features as they would have appeared at that point in time. From training a model perspective, you want your features, your model should almost be unaware if it's being trained in the forward pass. That means that the feature should look exactly as they would have looked if it was like the timestamp was now. And then it's only in the back prop step that we actually change things and kind of let it know the label. So we want to know the timestamp to build a point in time correct training set. And Featureform does that automatically. You just have to tell us which column is the timestamp. So we create the label. We create a feature, which is mean, which is the average. And it's again that rolling average that we did earlier. We create a feature, which is the customer's balance. And then we create a feature, which is that balance percent, which is the thing we defined earlier, which is the transaction amount divided by the balance. Specify the types, we can specify versions, we can add the description, we can do all kinds of other metadata here. I'm keeping this relatively simple. Once we have these, we can decide to also register a training set. A training set is for supervised learning, and there is made up of a single label column, or label rather, joined with n features. And again, we do that point in time join. So the 2 features I have in this one is the percent one, which I have here. The other one is the average transaction, which I have here. The label is fraud, the label is fraud. The name of this training set is just going to be fraud. And then we can apply this. So we apply. Notice that it creates, this creating is actually creating the metadata entry, as well as, in this case, I'm running it synchronously. It knows I'm in a notebook environment, so it will actually wait till these things are actually built. Even if you were using Spark or something and you did apply, it would wait until they were actually done, but you can make it run asynchronously. It runs, if you do, anyway, there's a lot of like nuance to that. You can look at our docs to understand when it does one or the other. But yeah, we did it. So we built these features and we updated the feature tables just to have Featureform ready to be able to serve these things. Awesome. Well, I just defined this whole DAG, and let's maybe real quick again, open up that dash. So Featureform dash, run this, go here. So now there's a training set, which is fraud. I can look at it, it's ready. I can look at the features that make up it, average transactions. I can look at the source, which is that Windows ags thing that we built. I can preview that if I wanted to. Like I can do all kinds of stuff to work with this. So there's a question, which is, do we need to define pass every feature one by one? And the answer is there's ways to do it without that or other APIs we have. In practice, the class API tends to be the cleanest one, but there are other ways you can do that. You can also, it's like, for example, if you wanted to register every or n columns in the same training set, there's ways to do that. It's a bit, I'd have to write it up, but it can be done, but the class API is typically what we recommend because it's usually the right thing to do. But yeah, there are situations where you want to register every column in like a big file, and that can be done as well. Great. So we have all these things. Awesome. That's nice. But now what, right? Let's talk about it. Now what we're going to want to do is we're going to want to train our model. So I'm going to go back to slides for a bit and we can talk about what we just did. So we used a notebook. We used the we used a notebook. We defined our DAG. And I'm going to explain what this fence is and why it's here. And we use that. We'll use that in a moment to train our model. The other thing is typically, I don't know if you've dealt with putting features in production, this might look familiar to you. The idea is that a lot of times as data scientists, we build our features, but then we need to throw it over a fence so that someone else, maybe an ML engineer, maybe someone else can go and actually productionize that feature. In Featureform, that doesn't exist. You just define your features and we will get them in production. And I'll get into that in a moment, what that looks like. But now that we've done that and defined these things, we'll be able to actually train the model. Oops, I'm going to get using this one. We're going to kill this again. So let's train them all. So the first thing we're going to do is so I can get, the client has a training set call. I can call fraud webinar. Webinar is the run, fraud is the name, .data frame. So you can, our train set API has two modes. There's streaming mode where you can stream mini batches. That's very useful in a situation where your training set is larger than memory, or you're maybe going from like a Databricks context to a different context. You probably want like stream in batches. Now in this situation, it's probably easier to just get it as a data frame. So that's what we'll do. So we'll run this. It's gonna, this actually builds it in local mode. If you're using Spark, it wouldn't build it right here, but you can see our training set. There's our two features and there's our label. We then, we have, we're going to import a random forest classifier, some other stuff from sklearn. So first thing we're going to do is we're going to split our label data frame from our feature data frame. So X and Y. We'll use a train test split. So we'll create 20 or 80% of our data to train, 20% of it to test. We'll create a random forest classifier, which is just a very simple model, works really well. And we'll use that to actually train. We'll fit it on, I should run this because it's going to take a bit. You should run this. If I'll talk over it as I'm running it. This is a relatively long operation because we're training a model on about a million rows. We're doing that split. We're fitting it on the training data. We're then gonna run it on the test data, and then we'll check the accuracy. So this is gonna eventually pop out a trained model in RF. Now we're working locally, so from that point we might deploy that model. And I'm gonna talk about how to serve, because in some situations, this might just be a batch model that we just run locally. In that situation, it's like ready to go. And in situations where you need to serve out of, for inference and production, especially for an interactive type model, that would be a model like fraud detection or a recommender system that is constantly online and constantly fielding requests. You're probably going to want to deploy that model. And so there we go. Accuracy is super high. We built this training set. We just generated the label based on relatively simple heuristics with some noise. So it's not surprising that it's super accurate based on very little features. In practice, a fraud model might have dozens of features, if not more. Great. Now we have this trained model. We want to serve for inference. And remember, our training set had two columns. There is the average transaction amount and the percent, which is the percent of, like, if you take the transaction amount divided by the balance. Now we have a problem. So average transaction amount is going to be relatively up to date, especially if we set up streaming, it will be mostly up to date. The problem with this percent feature is we can't pre-calculate that. So the value in the feature store is not going to be correct. What we want to do is create something that we would call an on-demand feature, which runs at request time, because we need request time data to actually generate this. I need to know at the time of the request what the amount of the transaction is. The way to think about that is with this. So there's batch features and streaming features. Batch features are typically run on a schedule. So Featureform supports scheduling. So you can run it every day, every hour, every week. And it will store the most recent values of the features in the inference store. For streaming, it works very similarly. It will stream data, and as new values come in, it will update the inference store. I should add that the other thing that streaming does isn't just update the inference store, it actually logs historical feature values so I can later train on those values, which is important. Now, that's for things that can be pre-calculated. And you would choose between batch features are typically easier, streaming features, there's more complexity on deploying, building, and maintaining those. Even with Featureform, it's definitely a bit harder. But you just ask yourself, how much does freshness matter? If you are dealing with a feature that doesn't change values that often and isn't like the changes are pretty minimal, then doing it every 24 hours is probably one, easier, and two, cheaper. In situations like when you have a feature such as the last 5 items a user clicked on, that feature value is changing quickly and constantly. So you want that to be a streaming feature. Now, on the other side of the inference store is on-demand features. On-demand features are features that have to be processed at request time, typically because they use request time data, like in this case, the transaction amount. So we will define the equivalent to the batch feature and an on-demand feature that can be used to maintain that value in production. There's work in the enterprise side of Featureform to actually make it so you can define it once, and it will be used in both on-demand context and batch context using a map function, but that doesn't exist yet. Great. So let's do that. So we're going to create this on-demand feature, on-demand percent. On-demand percent takes parameters and entities. So it takes a parameter, which is your transaction amount, and it divides it by the user's balance. Now, the user's balance we stored as a feature in Featureform. So we can do client.features, the same inference API we can use to actually within the on-demand feature. So we can run and apply this. This creates a new feature. And then I can call client.features. It takes a list. The list is going to be my 2 features, average transaction, on-demand percent. It takes parameters. In this case, there's just one, which is transaction amount. I just set it as 1,000. I specify a user entity. I just picked a random user. And if I run this, it's going to actually go and that's strange. It took a bit. Usually it's very, very fast. What it does is it has these 2 features. For one of them, it goes and looks it up because it's pre-calculated. If we were having this in production, we might have it in something like Redis, and Featureform will just pretty much almost immediately lobby it to Redis. So it's very, very low latency serving. In this case, it's just on your laptop. For the on-demand feature, what it's going to do is it's going to retrieve essentially this Python code, like a stored procedure, and run that on the client side. It will join both of these things together and give you the features. And then we feed that features or those features into the predictor that we created. And then it predicts that this is a fraudulent transaction. Great. Any questions? I know that was a lot of stuff very quickly. This is the end-to-end working thing. If you want to play around with this, you can go and change transformations, add new ones, etc. You can look at our docs. Our docs are just docs.featureform.com. We just got revamped. And yeah, any questions I can answer so far? Or so feel free to continue to throw in questions. I'm going to just go for the last thing I want to talk about, which is the part of defining and feature engineering that no one seems to really talk about. So I'm going to throw some memes at you again, just to give you a sense of it. So if you're here and you work at a big company, you might have features in production right now. In many cases, getting those features into production comes up with a lot of untitled notebooks, a lot of DF finals, a lot of table names like underscore V7, requires some ad hoc submits, some bash jobs. It's like kind of duct taped together. And there's very little documentation typically. This might also look familiar. So Featureform solves one set of problems, which is productionizing your feature. And there's another set of problems that it solves. It's providing a declarative framework for feature engineering. Before Featureform, it wasn't really the idea of a feature. It was just like a column, and we knew in our heads that that was a feature. With Featureform, all of these things, these resources, these artifacts are defined and managed and versioned by default and searchable and reusable. And you can use them across different notebooks, across different people. It adds that governance, that access control. So it's providing this kind of core framework that hasn't really existed before for feature engineering, which in many situations is most of what we're doing as data scientists, especially if we're working with machine learning. So that's kind of the other, let's call it core value of Featureform. So it's the questions of like, why would you use Featureform? There's many reasons, but there's two core ones I want to make sure you leave with, which is one, it makes getting features in production really easy. You don't have to throw things over a fence. You can do it yourself. You also automatically get monitoring. You automatically get scheduling. You automatically get versioning and all these things you would need for production. Also, it provides one standardized framework to define these things, manage these things, keep track of your transformations. So you can look at a training set, you can see the lineage, you can see how it was built, you can go on each of those steps, you can reuse any of the data sets, which wasn't really possible before. Awesome. If there's no further questions, I can give you back 10 minutes of your day. But I'll keep it open for a few more minutes in case someone else has any questions. There's one Q&A. What exactly do you mean by lineage? Great question. So lineage, so for lineage is the set of transformations to build a feature. So it's like transformation X, transformation Y, transformation Z builds the feature. Lineage is the ability to see that. So you can look at anything in Featureform and see exactly how it was built, which wouldn't typically be possible if it's like built across lots of different files and different things. You need something that stores the metadata and keeps track of dependencies, and Featureform does that. All right. A lot going on. I see that training says also stored locally. Is that the default? Are there other options like Parquet if we want to run Featureform locally and store in S3? Also, what if we don't want to use all data from a data source for training? Is that possible? Yeah, a lot of good questions here. So I'm going to answer them one at a time. I see that the training set is also stored locally. If you're using local mode Featureform, that is the default. We are working actively on joining local mode, what we call like hosted mode, in which case you could join them. Right now, if you were going to deploy Featureform in production, we support Spark, we support Snowflake, we support a lot of different processors. We support S3. We also support something that we call pandas on Kubernetes, which looks like pandas, but the actual jobs run as Kubernetes pods. And we'll run those and schedule those and orchestrate those. And in that situation, you can run pandas on S3 files. We store them in our format. We own that. We don't really let you mess around with that format only because we want the ability to change it based on the use cases and the ability to optimize that. It is stored as Parquet by default, though, as of now. Also, what if we don't want to use all the data from a data source in training? Is that possible? That is possible. So there's two ways to do that. One is you can, if you want to build the whole training set, but only train on a subset, you can do everything we just did. When you call client.training set, you can specify rows. So that's one way. If you don't even want to build it on the whole data set, let's say your data set's massive and you just want to sample it. One thing that I do all the time when I'm using Featureform is I'll create a transformation, which is just a head. Like, the transformation will be file.head 10,000. And my first transformation will just be cutting it to 10,000 rows that I can work with. Great questions. Thank you. Paki asks, what's the most challenging engineering bit in Featureform? Ooh, I'm trying to think what's not challenging or what's the most challenging. It feels like sometimes it's all very challenging. I think there's just a lot of pieces. I mean, one, like orchestration requires you to be really, really smart about edge cases because things fail, things go down. How do you do that? And how do you handle that? And how do you stay up? That's a huge engineering problem. Latency for serving is really critical. Maintaining and keeping a really low latency while doing all the things we need to do around monitoring, around governance, et cetera, requires a lot of caching, a lot of asynchronousness, and making sure that everything comes together in the end. Featureform itself is highly distributed. So anything in distributed systems comes with huge amounts of problems. Building these training sets in a way that is performant and correct. There's a lot of gotchas. Like the queries to actually build a training set are really long and really complicated. And there's a lot of like patches that we've had to add just to catch a lot of edge cases you wouldn't think about. So I think maybe the most challenging bit of engineering with Featureform is actually the edge cases. Getting something like Featureform to work in the simple way is really straightforward, but in the way in a sense where it works in situations where things go down, the Spark cluster went down, the job failed, and now it worked. HDFS sometimes connects and sometimes doesn't. That's really hard. I don't even think there's surely a million more things to hammer in there, but we've done a lot and put a lot of the work into making sure that our test coverage and our edge, we have good tests for edge cases. Cool, thanks me. Thanks for coming. One more question. Does Featureform have the capability to run transformations on a Dask cluster? We don't currently support Dask, but we really want to. If you need Dask and if it's something that you're going to help us with or work on, we are open source and we'd be more than happy we're actually about to enter like Hacktoberfest, so it's kind of top of mind, but we'd be more than happy to guide you through building a Dask integration. We have a Spark one, we have a Pandas one, so it will look similar. But we don't currently support Dask, but Dask and Array are both very much on our roadmap. Probably kind of, let's call it early next year, we'll probably have both. Right now, we're much more focused on Spark because most of our customers use Spark, honestly. Someone asked about on-demand features. Like, can I go through that again? And I'm happy to. So let me do that. Find that thing. Okay, so let's talk about on-demand features. So I'm going to define, let's say I have a feature, and that feature is the transaction amount divided by 10. I'm just making this up. When I'm training, right, I have the transaction, so I have the amounts, and I can just divide them all by 10 and batch. That's easy. But that logic, when I deploy in production, that feature, like the feature that's in the inference store, isn't useful to me because that was an old transaction. I need to know what the feature's value would have been for this transaction. So there's no way for me to pre-process that feature. Pre-processing exists for a lot of features, but for certain types of features, you can't pre-process them because they specifically require data at the time of the request. In this case, how much is the transaction? In those situations, those transformations, in our opinion, is still feature engineering. And you want that to be managed and stored in the feature store, even if the data itself isn't. You would want the logic to be managed in the feature store. So in that situation, we define an on-demand feature. In that case, we would just do, value divided by 10. That's all it would be, very simple. And when we serve that feature, we would retrieve that essentially Python function and run it in the client. So it works as a way to essentially store, manage, and deploy those different request time functions for things that can't be pre-processed. We also have on our docs, I have a longer write-up about this, but you can check out. So if I go to docs.featureform, if you go concepts, and we go to request time, canceling on-demand features at request time, you'll be able to read maybe a longer form style of what this is, and look at the code and maybe use that. I actually use the divide by 10 example here, so I didn't even realize I used it twice. Great question. I know there's a bit of conceptual parts of Featureform, which it's like once you've hit the problem, it's very clear, but sometimes it can be hard to describe until you see exactly where you need it. Then it's really obvious. But these are all things that we face or our customers have faced that we've needed. Request time features, on-demand features, those are one of the first and biggest things that we got asked for after deploying Featureform to our first set of users. Awesome. We actually made it to time. So I'll leave we have 2 minutes. So if there's any last questions, feel free to ask. Otherwise, I'm Simba at Featureform. You can join, we have a Featureform community, which you can join, which again, you can go to our docs.featureform.com, and they're on the top left. Featureform is open source. We do have an enterprise offering too. If you're interested in that, please let us know. We're happy to fill you in on the differences, what that means, how that looks. And yeah, hope this is useful. And Shab is going to send an email that will have ask for feedback. Please give us feedback. This is our first time doing this. So if you liked it, let us know. If you hated it, that's fine too. Please let us know so we can do better next time. And then there'll be other links there that will be useful. Did I miss anything, Shab?
No, I'll include a link to the notebook, link to the recording, as well as the community. Thank you all.
Thanks, everyone. I'll make you host, Shab, so you can end it so I don't screw it up.